Hello everyone. In this unit, I will be um, telling you about instructions for downloading the Bayesian decision analysis software. It is called the IHDA or IH Data Analyst Student Edition 2018 software. Uh, Before we get started, I should make clear that this software is designed for use on Windows-based PCs. It will not run on a Macintosh or Apple computer without an emulator being installed on it. So if you don't have a Mac or an Apple, I suggest you either work with someone who has a Windows-based PC or you install an emulator on your Macintosh and then run this software. Um, so you need to go to this particular website and click on this software. It's www.easinc.co/IHDA software. And when you go to this website, you will come to this IHDA. Actually, you will come to this page and you see several versions, and you need to click on the student version, which is the free software, and you can download it. There is also an IHDA Analyst professional software which you don't need to download. So the student version is free, and the website will ask you to register, which you can do. Once you have downloaded it and you click on the once you have downloaded and installed it, and then you click on the program, you will come to this opening page of the IHDA Analyst, and you will see several places where you can input information on the left hand side of the screen, and then on the right hand side you will have an empty space right now, but it will be filled with the outputs of your analysis. So in the top portion, which says facility information, you can input, if you want, information about the facility, the department, building, the type of process, and so on. And then you come to the substance information. So what is the chemical of interest? And then finally, most importantly, you need to put in an occupational exposure limit. So for the purposes of demonstration, let's assume that our substance is xylene, which we have been using all along in our examples, and the OEL for that is 100 parts per million. And I'm going to do a few example data sets and demonstrate the use of the software to analyze these data sets. So let's just assume that the first data set is 2 data points, or 3 data points, let's say 21, 68, and 45. And I enter them in the second column under the title, under the column heading CONC, or concentration. If any of these data points are less than the LOD, or limit of detection, you would put a less than sign in this column. But for now, let's assume that none of these are less than the limit of detection. So once you entered these 3 data points, and you have also entered the OEL of 100, the simplest thing to do is to calculate all. And you will see several pages of output appear on the right hand side in this window. And so the first window is the traditional statistics, or statistics. And there are several things that are shown here. The first one is the formal goodness of fit test, and it is the Philippians test, which we have encountered earlier in the course. And the interpretation is basically saying that the log normal distribution hypothesis is not rejected, meaning we can assume that these 3 data points come from a log normal distribution. Then there are order statistics, min, max, median, mean and standard deviation, and geometric mean and GSD. We also have the log normal compliance statistics that we have learned how to calculate earlier in the course. So the point estimate for the 95th percentile is 107. The exceedance fraction is 6.2%. And you can see even the point estimate now is greater than the exposure limit of 100. And so we know without even doing any Bayesian statistics that this is going to be a category 4 exposure. Then we click on the goodness of fit graph, and so we have 3 sets of charts shown here. The top one is a time series, assuming that these 3 data points are obtained in sequential order. But the main thing to look at is this middle graph, which is a log probit graph of the 3 data points. And you can see that on this log probit chart, the 3 data points more or less fall on a straight line, indicating visually that these data points also visually appear to be from a log normal distribution. And then finally we come to the Bayesian decision analysis charts, and this is our familiar stack of 3 sets of charts. The top one is the prior, and the software, unless you specify otherwise, will default to a uniform prior, meaning that there is 20% in each of the 5 exposure categories or ratings. The 3 data points are used to calculate a likelihood chart, and here it suggests that this is a category 4 exposure, as we expected even from looking at the point estimate of the 95th percentile. But it says that there is a 68% probability that these 3 data points come from a category 4 exposure profile, and about 31% probability that it's from a category 3 exposure, and a small 1.3% that it could be category 2 exposure. And since we have a uniform prior, the posterior is identical to the likelihood function. So this is a very simple run through of how to run this software. Let's look at a few other things now, a few other tabs, and look at some of its features. If you go to the left-hand side and click on the goodness of fit, and we can look at the different, there's a subjective evaluation, which is the looking at the log probit chart, or a objective evaluation, which is the actual goodness of fit Philibin's test. The next tab is the BDA rating, initial BDA rating, and we have several options here, and the default, as I mentioned earlier, is a uniform prior, meaning that there is 20% in each of the 5 exposure categories. But we can also pick a generic professional judgment prior, and so we click on this button, generic professional judgment prior, and we would say that the initial rating is, let's say it's controlled, and certainty level is low. And so this would be our initial prior. So there is 40% in category 3, 30% in category 4, and lesser percentages in categories 0, 1, and 2. I could change this to say, okay, it's a poorly controlled with low certainty. Then that means there's 40% in category 4 now, 30 in category 3, 21 in category 2, and so on. So we can adjust our prior to something that is not uniform. So these are the inbuilt priors for different initial ratings, ranging from trivial to highly controlled to well controlled to controlled to poorly controlled. And then certainty levels, high certainty meaning we are very confident that the probability in the category that we picked is high, or medium certainty, or low certainty. So that's a second way of selecting priors. A third way is to say, okay, I don't want a uniform prior or the generic professional judgment prior, but I'm going to use a custom professional judgment prior. And so here, what I do is I go in and put percentages in each one of these cells to make it add up to 100%. So let's say I pick 40% or 60% in category 4, and let's say 20% in category 3, 10% in category 2, and I need to just make sure I add up 9% in category 1 and 1% in category 0. And there's a box here which makes sure that the sum of all the probabilities add up to 1. Once you've done that, you post these changes. And then you go and do a calculate all. And so the traditional statistics and the goodness of it, none of these are going to change, but we can look at the BDA chart. And so now our prior is this new prior, custom prior that we have assigned, and the likelihood is as before, that arises from the data. And now the posterior is saying it's a category 4 exposure with a very high degree of confidence, so almost 86.7% probability that it's a category 4 exposure. Let me show a few other features of this software. So we can go to options and look at the Bayesian decision analysis. And there are several options that open up here. The first one that we can change is the boundaries of our parameter space. And so the default minimum GST is 1.05 and the maximum GST is 4. But we can change the maximum GST as we looked in the lecture to anything up to a GST of 20. Although these are very unusual occurrences, and if your sample GST is greater than 4, then you need to obviously adjust the parameter space to include that max GST in your parameter space. But it also means that maybe you should be looking at task-based exposure assessment strategies rather than shift-based exposure assessment strategies. You can also look at the exposure category cutoffs. So in our lectures so far, we have been assuming our standard 5 categories. The trivial category 0 is less than 1% of the exposure limit. Category 1 is 1 to 10%, so 0.1. Category 2 is 0.5 or 10 to 50% of the exposure limit. Category 3 is 50 to 100%, and poorly controlled or category 4 is above 100%. So these are our parameter spaces, but you can change these to some other boundaries if that's what you want to do. But for the purposes of this course, we will be using these cutoff categories. There are other options that that we really should. There's no reason to change any of these other settings. So that is the basic tour of the Bayesian decision analysis software, and you can use it to produce reports and charts. These charts can be copied and pasted onto your Word document without any problem. So with that, I'll stop this recording.